Here we go, 4.6 Watersheds. You get some super creepy water drops. Don't let it haunt your dreams. Okay, the watershed that we belong to, the Arroyo, Colorado watershed, because we are found in here along the Arroyo, Colorado. Not difficult. Now, the way water flows, when it hits land, it's more than likely going to end up in these little streams, the ones, which will flow and connect together into the twos, which will flow and connect together into the threes, and ultimately join these large waterways, the fours. Now, it does not mean that water will always move into four different bodies of water. What this is just showing is the general path that water takes. It goes from smaller to larger. All water ultimately ends up in the ocean, which is the biggest body of water that you can have. We have a little interactive activity in order to explore watersheds. It was a little juvenile, but it does get the information across. The characteristics that define a watershed: area, length, slope, soil, type of vegetation, and divides. Also, here in the background you have a pretty old waterway. You can tell because it has these large moraines, these large bends in it, and you have the beginnings here and here of an oxbow lake. Okay, so the area of the watershed, this is kind of like its size. Larger watersheds have the potential to gather more water, a larger volume of water. Over here we have the largest watershed in the US. This is the Mississippi River watershed. It gathers water from New York State all the way over to the edges of Idaho. Any water that falls in this area ultimately ends up in the Mississippi River and the Gulf of Mexico. The area of a watershed is also called the drainage basin. Think of it kind of like the bowl that will collect water that falls into itself. The length of the watershed, there's a couple of different ways that it can be measured. The most common one is based on principal flow path. So the path that the waterways flow through. It's not a very creative name. Slope, this is the angle of the land. Steeper slopes means your water is going to flow faster, it has more momentum, that increases its erosion potential. Slope also has an effect on local wind systems, which can also affect your waterways. The steeper the slope, the faster the water will flow. When you have very low slopes, you end up with these wide, flat floodplains. If you look in this picture, you don't have those floodplains because the water flows too quickly into this body of water. Okay, types of soil, we save that for our soil lesson. Vegetation. So the type of vegetation that's growing definitely has an effect on your watershed. The presence of plants is adding organic matter to the soil. Organic matter is pretty good at retaining water, so these soils tend to not be very dry. Tree litter, which are the leaves and broken sticks that fall off of trees, protect your soil surface from erosion. When that tree litter is on the ground, wind will have to get through that before it can get to your soil for erosion. Root systems, say this again and again, hold soils in place. So lots of vegetation, lots of root systems, your soil is nice and anchored. Tree canopies keep water cool. Some fish like cold water, some fish like warmer water. If you have a lot of trees in your riparian zone, that stream tends to be cooler than water exposed to sunlight because, obviously. The canopy also serves as a physical barrier between rain and wind and hitting the ground, so that's another way to protect your soil from erosion. And then the presence of plant cover provides habitat for critters. Then you have this vocabulary word, your riparian zone. It's the area next to waterways. There's not much specific to it, nothing special. Riparian zones are good for filtering out water before it makes its way into waterways. It's pretty good at catching chemical pollution. Okay, Now the divides, these are the physical barriers between your watersheds. It's a high point. Think of it like the edges of your bowls. It's the lip of the bowl. Our types of watersheds. We have agricultural. Agricultural watersheds are used for agriculture, for farming. There are ways to impact your watersheds that are not good. You can end up with these barren fields. Barren means nothing is growing. Soil can be compacted through the use of animals or machinery. When soil is compacted, there's not enough space in the particles for water to infiltrate into the ground, so your soil dries out. It makes it harder for more plants to grow there in the future. These areas don't have streams. The water is either used up for irrigation, or these streams are purposely diverted to get out of the way of valuable farmland. And you have a lot of these chemical synthetic fertilizers that are added to your soils that will inevitably end up in your waterways, which can cause that cultural eutrophication that we talked about earlier in the year. Urban watersheds. Urban watersheds are unique in that humans have altered them significantly, usually by covering them with impermeable surfaces. Impermeable means water can't flow through it. So underneath these impermeable surfaces, once the water's used up, that's it. Here you have an example. Your trees were cut down to make room for this house. You have fewer trees, so you have less evapotranspiration. There's less surface area for water to infiltrate into the ground, so you have more surface runoff. You have a house. You don't have those wide trees anymore, so you lose that canopy protection. So water and wind are hitting the ground harder than when the canopy is present. And because of these large impermeable surfaces, these areas are very prone to flooding. When Hurricane Harvey hit Houston, Houston is several square miles of cement, and there just was nowhere for the water to go. So the flooding was real bad. Mountainous watersheds, you have very steep gradients, so you have very low porosity soil, because soil doesn't have a lot of time to form on these steep slopes. It gets washed away too easily. Your soil is more mineral than it is organic material. Steep slopes have very little infiltration, lots of runoff, because the water doesn't get to move into the ground. It flows along the surface. And downstream of mountainous watersheds are very vulnerable to flooding. In the spring, when you get all this snow melt, you have a lot of water coming off of these mountains very quickly, so these areas will flood. Forest watersheds, you have a lot of evapotranspiration because you have a lot of grass, a lot of plants, a lot of trees. They're plant sweating. You have lots of infiltration and very little runoff because those soils like water. All those root systems in the soils like water. So when water falls, very little of it will flow off. Most of it will infiltrate into the ground. Here's just a quick reminder of the water cycle, how the whole thing works. Your desert watersheds. You have very sandy soil. Sand is the largest of the soil texture particles that we worry about in environmental science. The largest particles mean it's the most porous. The particles are further apart than in, say, a clay. So when there is rainfall, it soaks into the ground very quickly. It infiltrates. You generally don't have streams because the water will percolate into the soil. It doesn't stay at the surface. And you have very limited groundwater recharge, so if you're using groundwater, it's not going to replenish anytime soon. Then we have our coastal watersheds. These areas are typified by high rainfalls, a lot of local flooding, very high water tables that can be at or above the ground level. And these areas are vulnerable to saltwater intrusions. If you're overusing, let's say, a well here in this little complex of houses, that groundwater needs to be replaced by something, so that saltwater from the ocean can be pulled back in to replace it. Now that water is no good anymore. Then we have wetlands. Wetlands, very creatively named. This is land that is wet for either the majority or part of the year. You have a lot of rainfall and a lot of runoff. You have a lot of runoff because the water is already soaked. It's already waterlogged. It can't hold any more water. And you have a lot of evaporation in this area because you have very wide areas of land that are exposed to sunlight. What does water do when it gets hot? It evaporates. Now, most watersheds do not fit 100% into just one of these types of watersheds. They're mixed. For instance, here's our coastal, here's our urban, here's our agricultural, here's our mountainous. You have multiple different types of watersheds that all belong to one overall watershed. And then we had our question, what effects can dams have on watersheds? You have, first off, significant flooding upstream because all of this water is now being held back. You can see how big the river used to be, and then how wide it is now, how much taller it is. All of this habitat back here was donezo. You have reduced natural flooding downstream. Some of these ecosystems rely on these sediment deposits from this natural cyclical flooding, which is now gone. The water flow is controlled tightly. It's not allowed to flood down here. All of the sediment that flows in the river gets blocked by the dam upstream. Sometimes it can get so thick that these areas need to be dredged out. You need to go in and haul out all the sediment. You have increased evaporation here because you have a lot more surface area of water that's being exposed to sunlight. This water downstream can be warmer. As it passes through the dam, it can become thermally polluted, and the water at the bottom of this artificial lake is much colder than it normally should be. So you have critters or plants that prefer certain temperatures. Now it's much colder. In addition to being physically displaced by the rising water level, they can also be displaced by wrong, I guess is the word for it, temperatures. Then, what makes floodplains popular areas for human settlement? Lots of reasons. Water makes it easy to transport stuff. These areas have that cyclical seasonal flooding, which drops very sediment and nutrient-rich soils along their banks. So these areas are great for agriculture. And finally, it's a source of water to drink. Water is the only thing that's been discovered to be required for living things. The only substance that's known to be absolutely required for life is liquid water. So, if you're living near waterways, you have good agricultural areas, you have an excellent source of water, and it's easy to move stuff or people from one place to another. All excellent things. And then what factors need to be considered when building housing on a waterway? Contamination. Pretty simple. If you have your sewer lines, you need to make sure that they are built very well to avoid contaminating your local waterways. Nobody wants to drink the duty water. You need to be careful about gray water effluent coming out of these houses because you don't want to contaminate your waterways. And then we had a nice video. You guys can watch that on your own.